had it in Beach School yesterday.
Okay, guys. Lesson 5. We looked at these area formulas, tried to create some of them. As I just said, we're going to create them within problems. Now, one thing I didn't talk about before we left yesterday. Okay? 4 cross sections of area A taken perpendicular to an axis. So they're always going to describe to you the cross sections that I was just having you look at in your notes, whether they are perpendicular to the x-axis or perpendicular to the y-axis. Now, where they are perpendicular to will determine what variable you work in. Okay? So if my cross sections are perpendicular to the x-axis, so that means what I would think of as vertical cross sections, then we're going to be working in terms of x. Kind of like when we did area between 2 curves. Whereas if my cross sections are perpendicular to the y-axis, so then I'm thinking horizontal cross sections, then we're going to be working in terms of y. So you'll want to keep that in mind, depending on which way your cross sections go will determine which variable we are working in terms of. Okay, so let's look at A here. 1, whatever it is. Find the volume of the solid whose base is bounded by the function y equals square root of x equals 4, and the x-axis. Each cross section is a square taken perpendicular to the x-axis. Okay. Ready? Good news, they graphed it for us, yes? Always helpful when we do that. So y equals square root of x is this curve right here, yes? Just really wrote that on top of the other one. X equals 4 is this vertical line that just ends my boundary, and then the x-axis. So right there is this base we are working with. Each cross section is a square perpendicular to the x-axis. So that means the base of these squares are going to go this direction, right? Perpendicular to the x-axis. So there's a base of a square. Now, we're looking at an infinite amount of cross sections, right? And so that means it's square next to 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 square. Realize these squares are going to get smaller or wider, depending on which direction you go, which means they're also, as the square gets skinnier, it's also going to get shorter. As it gets wider, it's going to get taller, right? And about the best I can suggest if you want to, it's really hard to draw a three-dimensional shape in here, but it's the idea, I don't know. What I'll often do is draw it at an angle that, like, there's your square. That's not a good example. I don't know how to, draw it. But you've got this square standing up, right? Next to infinite amount of squares next to each other standing up. Now, how do we find area of a square? Just based on what you know. Okay, length times width, except we know length and width are the same, right? So you'll hear side squared, or I feel like in these notes they tend to use base as in b squared a lot, right? Now, with that in mind, how do I want to think? Okay, so if I think b squared as in the base squared, okay, and that's what we had on the other page, right? So b squared, s squared, whatever you want. In this particular case, keep in mind, the base of the square is a vertical distance, right? Is a vertical distance an x value or a y value? In other words, if this is counting up, this is a y value, correct? So when we talk about that base has a length of y. So I can also think of this as y squared. What do we know? What equation were we given? What equation are we working with here? The equation was square root of x, yes? So what do we know y is the same as? Y is also the same as y equals square root of x. So square root of x squared. okay, which is just going to be x, yes. Okay, so our area formula for the area of this square, that should be side times side, base times base. In this case, my side goes from the x-axis up to this curve, and this curve is square root of x, right? Y equals square root of x. So since it's a vertical distance, it's y, but I can sub in square root of x there. So what we're going to be doing is we are integrating area. So in order to find volume, we're going to integrate area. So we're going to be looking at the integral of square root of x squared dx. I'm writing square root of x squared so you can see where it came from. Yes, that is going to become x. Now we're working in terms of x because this was perpendicular to the x-axis. I need boundaries. What are my limits or boundaries here? Okay, so if we're looking on the x-axis, we're going from 0 to 4, yes? So if you're working in terms of x, you need x values. And there's your first problem. Do the math, right? So the integral from 0 to 4 of x dx is what it ends up to be. The integral of x is 1/2 x squared evaluated from 0 to 4. Half of 4 squared, which is 8. Okay. There's a basic example to get us started. Questions on that one?
So what are we trying to figure out?
We're trying to figure out volume. But so in order to figure out, because what we're...
So is this like a 3D figure?
Because the cross sections are like what you see on that last page of your notes there. Where, so if you turn to page 472, they're gonna look like those type of things. Okay, so this you have to imagine we'd have small squares, bigger, 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 bigger. So this would be getting wider and going up.
So that's a cross section or that's a 3D?
The cross sections are squares. So what this is square next to 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 square. But as my squares are getting skinnier, they're getting shorter. As my squares are getting, because what do we know about a square? The length of the base is going to be the same as the height. Okay? I'm not 100% sold, I can tell.
So this is like we're looking at the side of it.
What do you mean? I'm done.
Like of the 3D shape, that's like one of the sides of it, and then there's cross sections there.
Yeah, like the whole thing. Basically, if you take it and slice it, on either side of what you sliced is going to be a square. Okay, any place you slice it, perpendicular to the x-axis, is going to be squares. Okay, square on this one, because to the left you're going to have smaller squares, to the right you're going to have bigger squares. Because we're looking, it's the idea of I'd have a little square here, bigger square, bigger square, bigger square.
So it's like half an apple slice. Well, no, that'd be triangle.
I don't even know. I don't know how to respond to that one.
Maybe if you keep going.
And the thing is, it is really, really difficult to draw these pictures. Okay, I for one definitely can't do it, but even the artists out there are going to struggle with, okay, how to draw these pictures. So, and that's why I suggested, okay, check out some of those pictures on 472 because that gives you at least kind of an idea of what you could be visualizing. And so, like, if you look at the top picture on 472, those squares are cross sections, right? So the difference is there that the shape it looks like is you know, like maybe almost two parabolas going opposite ways or whatever. So you'll notice at one end the squares taper down to be nothing, and like in the middle they're big. This would be like us having like half of this, if that makes sense. The tiny end would be right here, and then over here at 4, this would be like us slicing into the middle where that gray rectangle is. I'm not going to say it's going to have exactly the same shape, but similar in idea. Okay. Okay, let's try example 2. And I would say the difficult part about this, every problem changes. Okay, we just did one with a square. Now we're doing one with the base is a circle, but my cross sections are isosceles right triangles. Okay, yeah, so there's a lot to think here. Okay, so find the volume of the solid whose base is a region bounded by the circle, x squared plus y squared equals 9, with cross sections taken perpendicular to the x-axis that are isosceles right triangles with a hypotenuse lying on the base of the circle. Okay. This probably goes on the other end of the spectrum. I feel like this is an easier one. This is probably a little bit more difficult one. Okay, let's see here. So first of all, this whole curve is x squared plus y squared equals 9. We are working, what was it? Perpendicular to the x-axis. So when we say perpendicular to the x-axis, that means a base of my triangle is going to run from there to there, if that makes sense, right? I'm not going to try and draw the triangle right now. Okay? But that's the idea where the base of the triangle is. But that'd be one base. Obviously, there's an infinite amount, right? Because this is perpendicular to the x-axis, we're going to be working in terms of x, which means I need to take this equation and solve it and put it in terms of x, which means I need to solve it for y. So what do we know there? Y squared is 9 minus x squared, and y is plus or minus 9 minus x squared. Oh, I might have been able to stop at y squared on this one. We'll see. Realize when we say y equals plus or minus the square root of 9 minus x squared. The positive square root of 9 minus x squared is the top half of the circle. The negative square root of 9 minus x squared is the bottom half of the circle, yes? Okay, so that's when they say plus or minus. That's what we're looking at here. Now, isosceles right triangle with specifically hypotenuse lying on the base of the circle. So if you go back to the areas we did yesterday, isosceles right triangle with hypotenuse as a base, there's a visual for you if you need a visual. Okay? So there's your visual. I'm going to, down here, there's my isosceles right triangle with hypotenuse as the base, right? Now, because this is a vertical distance on my graph, that means this distance up from the x-axis is a distance of y. What about the distance going down from the x-axis? It is also a distance of y. So earlier, we were only above the x-axis. So we just had a single distance of y. Here, we are below and above the x-axis. So we're going to end up having a distance of not just y, but that base is going to be 2y, if you will, right? Because y plus y is 2y. Are you seeing that with me? Now, in order to do area of a triangle. What's area of a triangle? The basics we know are 1/2 base times height, right? 1/2 is 1/2. My base of this triangle is going to be 2y. What's the height of this triangle? Can't even read my own handwriting about what I was trying to do there. What kind of triangle was this? It was isosceles, right? Isosceles right triangle, which means technically this is a 45, 45, 90, yes. When I take this and split this into two right triangles, right? Are you following this? By drawing the height here, I split it into two right triangles. Well, if this leg on the bottom are each y, what's it make my height? Makes my height a y. I don't know if you guys can really read that. This is getting... That makes my height of the triangle a y. So what I'm trying to lead you to is area is going to be 1/2 times the base of the triangle, which is 2y, times the height of the triangle, which is y. You can clean that up if you want. 1/2 times 2, half of 2 is 1. Y times y is y squared. So we can use the idea that the area is y squared in ours. Now, what are we going to use for y, though? We're going to go back and use the equation, yes? Because it's perpendicular to the x-axis, we're working in terms of x. So, and technically, this is where I realized we actually have y squared right there, don't we? Or the square root of 9 minus x squared, when you square it, you're going to get 9 minus x squared. Okay, so let's try and set this volume up here. The volume. Okay. We're integrating area. Okay. So my area is y squared. What am I using for y squared? 9 minus x squared. Or you can say it's the square root of 9 minus x squared squared. But then you just end up at 9 minus x squared, right? So it's going to be integral of 9 minus x squared dx. What is my interval here? -3 to +3? Now, that's one correct way to solve it, or write it. I'm going to give you an or option. What do we know about this circle? Okay, symmetric. There's my official mathematical word. So instead of doing, and I'm not opposed to you guys doing -3 to 3, but here's the idea. You're going to have to plug in 3 and you're going to have to plug in -3. As opposed to, what's the other option I can do? 0 to 3 and multiply that integral by 2. Now, is one of them more right or wrong than the other? Neither of them are wrong. There's not a more right here. The easier math is to do the 2 times 0 to 3. That doesn't make the other one wrong at all. It just means when you have to plug in -3, you're a little bit more likely to make mistakes. So I'm going to say, or you can do 2 times the integral from 0 to 3 of 9 minus x squared dx. And you know how to do the math from here, right? So I'm going to keep that 2 out front. I'm going to integrate. So 9x minus 1/3 x cubed, evaluated from 0 to 3. And in this one, I think it's worth it, because am I going to have to plug that 0 in at all? No, always check. Don't just assume you get to ignore 0, but it's not going to do anything. So 27 minus a third of 27, which is 9. 2 times 18, which is 36, if I've done my math correctly. Even better. The answer key agrees with me. Okay. I said it's a lot, isn't it?
I mean, it makes sense on here. Just thinking about how I'm going to replicate this.
On your own, right? Exactly. Right now I'm leading you through it. I can make it make perfect sense. You have to be able to do this on your own, right? And I will say, homework took me a while last night, and that was me. So I'm giving you that heads up now. It's going to take some thought. So
this is a circle, right? And
Uh-huh.
there's triangles.
yes. So this right here is coming up to be triangles.
Making a circle.
The base is a circle. And then so at the end, you're going to have little tiny triangles, right?
Triangle.
Baby triangle. Then they get a little wider, a little wider, a little wider. And then when you hit the middle, it's going to go back down.
Okay, got it now.
You're trying to visualize that?
So is it kind of like a
So
little,
it's like a cone.
little dome? Basically, could you think of it like that?
I'm trying to think. It's kind of,
It's got like the.
it's not a cone in that because there's going to be a ridge across the center. It's not a cone that everything comes to a point. But because there's going to be a top of the triangle right here, and it's going to go up to the highest one and then curve back down. So the top of the middle of your triangle points are going to curve up.
Okay.
If I do some searching online, I can probably find a picture. I just forgot about that aspect, huh?
Should I play Snow? I'm so confused.
Okay, so note to self. That is my homework for tomorrow. I need to find some pictures
So you
too.
have to look at this object. Like this is obviously like a cut
Yeah.
of the object, but the object could be like a little like dome or like a little button that you could hit because it's like.
Other than there's going to be a ridge in the middle. Because these are triangles,
Oh yeah.
right?
Yeah.
So the thing is, am I going to be able to find a picture for everyone? No, that's the thing. So, okay, example 3. Let's try them. Let R be the region bounded by the graphs of x equals y squared and x equals 9. So x equals y squared, we know that's a sideways parabola, right? X equals 9, that's just a vertical line. Basically, that's just telling you to stop here. Okay, we're not going on infinitely, excuse me. Find the volume of the solid that has R as its base if every cross section by a plane perpendicular to the x-axis is a semicircle. Okay, so we're still perpendicular to the x-axis. Now we've got to talk semicircles. Okay. So if I draw, oops, and I tend to just pick a spot, drawing a random cross section here, right? And so I can't do it justice, but the idea that there'd be a semicircle. There's going to be a bigger semicircle over here. There's going to be baby semicircles over here, right? Oh gosh.
This one's like half of the cone.
Okay, but it's back to back to back. And you don't have to draw all those in. I don't know, that might have been a bad idea, but. Again, these are perpendicular to the x-axis, so we're going to work in terms of x, aren't we? So one of the first things I'm going to do is I'm going to take my equation, and I want to know what it is when I say y equals. And it is y equals, officially plus or minus the square root of x. I'll be honest, most of the time we end up just needing the square root of x part, but out of habit I put it there. Again, because we are perpendicular to the x-axis, These are y values, right? That's a y value. And because this one goes above and below the x-axis, that's a y value, correct? Okay. Think about our area formula. And I know we did area of a semicircle yesterday, but I still feel like it varies a little bit, and we need to, I don't think you're going to memorize all those formulas. So maybe you are. Okay, so what do we know about area of a semicircle? That's what I'm always starting with, is what's my basic area? Okay, area of a circle is pi r squared. Semicircle, 1/2 pi r squared. So, and the 1/2 times pi, you're probably going to see as pi over 2 a lot. Okay. What is my radius?
2y.
Is it y or is it 2y if it's the radius of the semicircle?
It's y.
That's a weird way to do radius.
Because radius is just halfway across the semicircle. Trust me, we won't talk about how long it took me to figure this out last night. I was tired. It was not happening very well for me last night. I couldn't figure out. I was missing a 2 in her work, and this is why. A radius is just going to be y. Do you see that? This is the only time this happens. The circles get us. Okay, so just beware. So this is going to be y squared, if you will. Not 2y squared, just y squared. So you can think of this as pi over 2, because those are just constants. You can think of it as y squared here, and then you can fill in what is y. Actually, you can fill in this, or what is y squared there? Y squared is what? X. So really my area formula is going to be pi over 2 times x, isn't it? Or think of it as, if that's going to confuse you later when you look back at it, think of it as square root of x squared. Right? Okay. Can you write your volume formula? The area we're integrating is going to be pi over 2. If I want, I could say the square root of x squared, right? If you want to go that way, in case you need to look at it later, square root of x squared dx. What are my boundaries? Okay. We're in terms of x again, so 0 to 9. So you can pull that pi over 2 out front, the integral of 0 to 9 of x dx. And you can do that basic math, right? Carrying my pi over 2 down, integrating pi over 2 times 1/2 x squared, integrating from 0 to 9. I can go ahead and put the pi over 2 and 1/2 together, and it's pi over 4, if you will, times 9 squared minus 0 squared. Pi over 4 times 81. 81 pi over 4 is what I end up at. I know. I'm going to have to add a day for 8-5 tomorrow. There's no way.
Finish 8-4 and then start 8-6.
I don't know. We'll see how homework goes. That's going to be the real thing. Is I'm going to need you guys to try the homework, and let's see, do we get to a point where you can do this on your own, or are we going to need to talk about the homework a lot? Like, I don't know. Okay. 4. Find the volume of the solid whose base is the region bounded by the lines x plus 2y equals 6, x equals 0, y equals 0, cross sections taken perpendicular to the y-axis are equilateral triangles. Sorry, I'm laughing at Ethan's face here. His jaw was hanging open there. Okay, and on top of it, didn't give us a picture. Okay, you guys realize when they say x equals 0 and y equals 0, we're talking about the axes, right? And so basically we're just talking about the first quadrant section. What do you know about x plus 2y equals 6?
Negative x, well, negative 1/2 x, and then plus 3.
Okay. If you go and solve, and here's the reason I'm solving it. I can't, x plus 2y equals 6. I could graph that by throwing in some zeros. Actually, that might be your actually easiest way. Is if I throw in, do you see what I mean by throwing in zeros? Because if I put in 0 for y, what is x? You know what? I'm not even going to bother with the tick marks. Forget it. If I put in 0 for y, x is 6, correct? If I put in 0 for x, y is 3. Or, like Ethan was doing, solve it. 2y equals negative x plus 6. Y is negative 1/2 x plus 3, right? Somehow you got to graph that line. Okay. Specifically, I don't even know if I want to try and shade this. Specifically, we're talking about this area in here, right? Like that is our base. That is what we are working with there. Perpendicular to the y-axis. What just happened? Changing it up, aren't we? Hey, we got 3 in a row where they were all perpendicular to the x-axis, so be thankful for that, right? Because those are always the easier ones, of course. Our brains work better in x. Don't ask me why, but they do. So perpendicular to the y-axis, which means, what kind of distance is this? If this measures left to right, this is a distance of x, right? Now, that also means when we talk about putting this equation into our, because we are talking perpendicular to the y-axis, we're working in terms of y. So I need to know what is this equation when it's solved for x. So I'm also going to have to know that this is x equals 6 minus 2y. Because we're going perpendicular to the y-axis, we're working in terms of y.
So I have a question.
Yes?
What do these little triangles look like?
Huh?
Like, what do the triangles look like? Is that like their height, or is that where their sides? Like, where are they?
So the x right here, this is the base of the triangle.
Okay.
And it's equilateral triangles, right? So you've got triangles that are going to stack like this.
Okay.
Over here, they're going to get wider, right?
Okay.
Over here, they're going to get skinnier. I'll be honest, I can't visualize this one exactly. I'm trying, you know, because on top of it, the points of the triangles are going to be going at an angle here. Like, I don't know. I can't exactly visualize this one. Now, okay, I am going to bring a side note down here. Because here's the deal. We have to get all of our information for our formula, don't we? So I'm going to draw myself an equilateral triangle here that I can work with. As we talk about an equilateral triangle, well, let's see. We know area is 1/2 BH, yes? In representation of this picture, my base is going to be x, correct? It's our base, and because it's a horizontal cross section, it's going to be x. Now, this was a equilateral, right? So we're talking a 60, 60, 60. But here's the deal. I need to know the height of that thing. In order to know the height of that thing, this is going to break up into two 30, 60, 90s. Are you seeing it? The bottom of one of the 30, 60, 90s is going to be 1/2 x, if you will, right? So the whole base was x, but thinking in terms of the 30, 60, 90s, it's 1/2 x, 1/2 x. Okay, think about your 30, 60, 90 rules. 1/2 x is the short leg, the short side. It's opposite the 30. To get the hypotenuse, which I don't need, we do 2 times that. Well, guess what? 2 times 1/2 x is x, which is an equilateral triangle. It should be x. To get the long leg, you take the short leg and multiply by square root of 3. Remember that 1, 2, and square root of 3 on the 30, 60, 90 over there by Maddie's head? Yeah, there's your relationships, right? The short leg is kind of your base. It has a relationship of 1. The hypotenuse is twice that. The long leg is square root of 3 that. So that means here I'm going to do square root of 3 times 1/2 x, or in other words, square root of 3 over 2 x. Because if you think it's square root of 3 times 1/2 x, which I'm going to write as square root of 3 over 2 x. And that's my height. Okay. Yes?
How do we get 1/2 x?
Because the whole base was x, and then we had to break it into two 30, 60, 90s to be able to find the height. Okay, so did you guys come up with an area formula for yourself? 1/2 times the base. What was the length of my base? The whole base, x, times the height, which is square root of 3 over 2 x. Square root of 3 over 4 x squared. I will say, as random formulas go, knowing the area of an equilateral triangle is helpful in AP. Okay? The area of an equilateral triangle, that square root of 3 over 4 times x squared, where x is just one of the sides, that was in my old AP notes too. I remember that was one on a list of formulas to know. That was a suggested no one. Now, can you also come up with it like we just did? Of course. Okay, so, we ready? Who knows, right? There you go. V equals. We're integrating area, yes? My area is square root of 3 over 4 x squared. What am I putting in for x? 6 minus 2y. So 6 minus 2y, quantity squared, with respect to y, so dy. What? 0 to 3, because we are in terms of y. Okay. I personally am going to pull that square root of 3 over 4 out front. And I personally am going to FOIL this out to integrate it. I don't know. I saw recently where they did not FOIL this out, but it was on an easier one, though, so maybe they would here. Who knows? 36 minus 12y minus 12y. So minus 24y plus 4y squared dy. Reverse that if you want, or work with it in this sense. Again, keeping my square root of 3 over 4 out front. (36y) minus 12y squared plus 4/3 y cubed, evaluated from 0 to 3. Square root of 3 over 4. 36 times 3, 108. Minus 12 times 3 squared, 12 times 9, 108, I think. Plus 4/3 times y cubed. 3 cubed is 27. Divide that 3 out is 9. Times that 4 is 36. So I end up with square root of 3 over 4 times 36 when my 108's cancel. So if I cancel my 4, I'm at 9 square root of 3. Okay. Here's what I'm going to say. You've seen the basics. You really, truly have. Okay? You've seen the basics. Based on, there's a lot to do with the homework. Okay? You will notice that some of them say calculator, some of them say no calculator. So you can kind of watch that. 'Cause there's a group where it's maybe towards the end or where it's calculator active, I guess. But the ones we can't do are the ones where you have different upper and lower ones. We haven't talked about those. But I would strongly encourage you to try some of these for tomorrow. I am going to have to probably finish the notes. I don't think there's any way I can. I feel like if I rush too far past this section, it's not gonna click. So, yes.
So, the 30, 60, 90 isn't equilateral, like in use.
No. 30, 60, 90 was 1/2 of this. But I took my 60, 60, 60 and divided it into two 30, 60, 90s.
What's the isosceles?
Isosceles, if it's a isosceles right triangle, it's a 45, 45, 90. So it would follow our 45, 45, 45, 45, 90 rules.
Equilateral is 60, 60.
Uh-huh. Yep. Okay. As I said, it's fresh in your head. Try some of it, okay? Don't stress about getting every problem done right now, but try some of them and see where it puts you. Because my thought is the more you try them now, then when you come back tomorrow, your brain will be ready to grow a little bit more maybe and put it all together.